Imagine you click a website, and its main server is thousands of miles away. Your request has to cross the internet, travel through multiple networks, reach the server, and come all the way back. So why does the website still feel almost instant? Here's the surprising part. Your browser often isn't talking to that main server at all. Somewhere much closer to you, another server may already have exactly what you need. That's the secret behind CDNs. But how does that actually work? The first problem is latency. Data travels extremely fast, but it still has to travel. Physical distance, routing, network congestion, and multiple network hops all add delay. So instead of forcing every user to reach one central server, CDNs distribute servers across many locations. These are commonly called edge servers, and the closer the content is to the user, the shorter the network journey can be. But geographic proximity isn't the real magic. Here's where it gets interesting. A CDN can keep copies of frequently requested content in its edge cache. Imagine your browser needs a JavaScript file called app.js. The first request reaches a CDN edge, but the file isn't there yet. That's a cache miss. The CDN retrieves the file from the origin and can store a copy at the edge, depending on the caching rules. Now another user requests that same file. This time, the CDN already has it. That's a cache hit, and the request can be served directly from the edge. So what actually happens when you load a website? First, your browser needs to resolve the website's domain through DNS. The resulting network routing gets you toward the CDN infrastructure. Your browser then makes an HTTPS request to the CDN. The CDN receives the request and checks its cache. If the response is available and still usable, you get a cache hit. The CDN can return the cached response directly. But if there's a cache miss, the CDN has to obtain the content from the origin. The origin sends the response back through the CDN, and the CDN may store it for future requests according to its caching policy. So the critical decision happens right here. Does the edge already have a usable copy? And this leads to one of the biggest misconceptions about CDNs. A CDN doesn't make your origin server magically faster. Your application server still has the same CPU, memory, database, and application code. What changes is how often users need to reach it. If a million users request the same cacheable image, the CDN can serve many of those requests from its edge infrastructure instead of sending every request back to the origin. That reduces latency for users, and reduces traffic and workload at the origin. So what gets cached? Common examples include images, CSS, JavaScript bundles, fonts, and videos. Some systems can also cache HTML pages or API responses. But that's where things get more complicated. Personalized responses, authentication, cookies, cache keys, and HTTP cache control rules can all affect whether something should be cached. This architecture is one of the reasons the modern web can serve enormous numbers of users around the world. Streaming platforms, e-commerce sites, social networks, and modern React applications can all benefit from distributed edge infrastructure and caching. Instead of making every user travel to one central location, the system brings frequently requested content closer to them. So here's the simplest mental model. The origin creates the content. The CDN distributes copies of that content closer to users. When the edge already has what you need, your request doesn't have to make the long journey back to the origin. That's why CDNs make websites feel fast, not because they break the laws of physics, but because they make the data travel less.